last module, we learned how to distinguish mutable from immutable data, use different Python data structures, and create our first Python function. For our last module, we'll be dealing with string manipulation and file input and output operations, all while utilizing functions more. I'll also be introducing a powerful tool called the Jupyter Notebook. My name is Sean, and welcome to the last stretch of this course. Remember in the previous module that strings are also considered sequential data structures since they're just sequence of characters? This factor allows users to analyze and handle strings in a versatile way, character per character, segment per segment. This process is called string manipulation. There are a lot of things you could do with the strings, not just in Python, but in other programming languages as well. One of the common things is the letter case, or the way strings are capitalized. Just by using the built-in methods, we can change the strings into uppercase, lowercase, and even title case, which isn't easily doable in other languages.
Let's say we have a variable called this_word containing the string value hello friend. We can convert this into uppercase, lowercase, and title case by using the upper, lower, and title functions simply by calling the variable name, followed by a dot, function name, and parenthesis. Therefore, once we print this, the letter case will be different. Aside from this, we can capitalize the first letter of the string and even swap cases. We have the capitalize and swap case functions for this. With the same syntax as the others, we can produce our desired result. Now, remember when I said that strings are immutable? This means we can't manipulate strings permanently without having to reassign them to the same or another variable. This means using any of these functions won't change the current value of the variable. Now, if we're going to reassign the variable to contain the manipulated string, that's the only time the output will change. And this isn't because we're able to change the string. Since strings are immutable, what we're actually doing is creating a new value by reassigning it to the thisWorld variable.
Another common thing we can do with strings is check its characteristics. These built-in functions all return a Boolean value of true or false, depending on the characteristic you're checking for.
First off the list are the alphanumeric checkers, isAlnum, isAlpha, and isDigit. The isAlnum function checks if the string is composed of either alphabets from A to Z, numbers from 0 to 9, or a combination of both. The isAlpha function, on the other hand, checks if the string is composed of only alphabet characters. The third function, isDigit, is just like isAlpha, but instead of alphabets, it's checking if the string is composed of only numbers. Now, let's say we have the thisWord variable with a string value of abc123 and check it using the three alphanumeric checker functions. As you can see, only the isAlnum function returns true. This is because isAlpha detected digits in the string, while isDigit detected letters. For the latter two to return true, the string should be either purely letters or purely digits. Second of the list are the letter case checkers, isTitle, isUpper, and isLower. Basically, these three functions check if the string is in either title case, uppercase, or lowercase respectively. Now, if we go ahead and use these checker functions on our variable, but this time with the value "this is a sentence" in lower caps, only is lower returns true since the string is neither in title case nor in uppercase. Aside from this, we also have functions to check for certain characters in a string: isSpace, ends with, and starts with. Just like the rest of the built-in checker functions, this is quite self-explanatory, so let's proceed with an example to understand it better. As you can see in the ends with and starts with functions, we're passing the value we're looking for at the end and beginning of the string. The isSpace and ends with functions return true since the string has spaces and it also ends with a period. The starts with function, however, returns false since the string starts with lowercase t, not capitalized. So bear in mind when using starts with and ends with that the parameter is case sensitive. Now, did you know that there are other functions available to help you check or find characters in a string? We have the built-in function find. This function lets you find substrings or a subset of characters regardless of its position in the string. It then proceeds to return the index of its first occurrence if it finds that substring. Let's try this function to find the substring is in our thisWord variable. See how it returned 5? This is because it's the starting index of the first is in the variable. Let's verify this by printing the sentence from index 5 onwards. Let's go ahead and type in the name of our variable, followed by square brackets. Inside the square brackets, let's type the index returned, which is 5, followed by a colon. See how the string printed started with the first is occurrence? Now, let's tweak the values inside the square brackets a bit by adding 7 right after the colon. Now we're just saying is on the console. But what is this really? What we just did is called slicing. We're using the indexes to extract substrings. The syntax inside the square brackets denotes the characters to extract. When we type inside the square brackets 5:7, we're actually telling Python to just extract the characters from index 5 and 6. Why does it say 7 then? This is because 7 actually marks the beginning of the excluded indexes. Therefore, when we say 1:3, we're actually saying to include indexes 1 and 2, but excluding 3 onwards. But what about 5:? This simply tells Python to extract the characters starting from index 5 onwards. We can also declare :5, which is the complete opposite. It will extract from the beginning of the string, but excluding index 5 onwards. Now, what if we simply declare 5? Can you guess what will happen based on how we use indexes in lists? What will happen is it will print the character on index 5. Nothing more, nothing less. Lastly, we can also use negative digits as indexes when slicing or extracting substrings. What this does is it parses the characters from the end, not the beginning. Therefore, if we use -1, it will print the last character of the string. Now, going back to the find function, what if the character we're looking for is not in the substring? What the function will do is return -1. This is a constant return value, so we can use this as a checker through conditions. Lastly, let's proceed with string manipulation using the replace, strip, and split functions. Again, the function names are self-explanatory, so let's dive right into examples. Using replace, we can replace all occurrence of is with was in the thisWord variable by passing the substring to replace and the new substring as parameters. Now, if we want to make this change permanent, since strings are immutable, we need to reassign the value to our variable. The strip function, on the other hand, helps us get rid of trailing characters or white spaces whenever needed. This is particularly useful for file operations, which we'll get into in a minute. For example, we have a variable named line with a lot of trailing white spaces. By using strip without a parameter, we're able to get rid of the trailing white spaces. Now let's remove the XX markings at the beginning and end of the string by passing it to the strip function as a parameter. Amazing, right? Lastly, we have the split function. This converts the string into a list of strings based on the separator value we're passing as a parameter. Therefore, if we use hello Python as a string value, we can store each word in the list by using the split function with the space serving as the separator value by default if no parameters are passed. And just like that, we learned how to do string manipulation using various built-in Python functions. Now, let's try to utilize this in file operations.
When we say file I/O, we're referring to file input and output operations, meaning you can read and write files in Python. First, let's walk you through the file opening concepts. Python comes with access modes when it comes to opening files. These are denoted by specific symbols which needs to be passed along with the file path when opening a file. The first access mode is the read mode, denoted by R. This is in fact the default access mode when opening files. Second, we have the write mode, denoted by W. This should let you overwrite the content of an existing file. Otherwise, it will create a new file for you if the file path specified does not exist. Third, we have the append mode, denoted by A. This lets you add data to the file without overwriting its current content. Lastly, to read and write or read and append, you can use R+ and A+ respectively.
To open a file in Python, we'll use the syntax with open as variable name. This takes care of safely opening and closing files for you to avoid corrupting them in any way. Simply type in with open followed by an open and close parenthesis, followed by as variable name and end with a colon. Inside the parentheses, you should specify either the file path or file name, optionally followed by the access mode. Now, let's try to create our first file as an example. For the file name, let's name it example.txt. For the access mode, let's use the write mode. For the variable name, we'll simply go with file. Again, just like if-else statements, loops, and functions, be mindful of indentations. For the content, let's just add hello world and hello Python. There are two ways to do this. through the write function and the writelines function. The write function is best used for single-line values. The writelines function, on the other hand, is useful for multiple line values. In this case, since we have 2 lines to add, let's use writelines. We could declare each line simply by passing a list of strings, each index containing a string value, as its parameter. To spice things up a bit, let's wrap this in a function named FileWriter to make it reusable. You might be wondering what the \n at the end of each string is for. It simply tells Python to create a new line at the end. Once we save your Python script, you should see a new file named example.txt containing hello world and hello Python. Now, if we want to just add new data to an already existing file, we can use the append mode. For this, let's create a function named fileAppender. Once we save your Python script again and check example.txt, it should now contain hello world, hello Python, goodbye friend, and goodbye Python. Now, let's proceed with opening and reading files. Python comes with 3 built-in functions to read them: read, readline, and readlines. The read function simply extracts the entire content of the file. The readline and readlines functions, on the other hand, require the use of loops due to their nature. The readline function only extracts one line from the file at a time, while the readlines function stores each line as an element of a list. Let's try using the readlines function to store each line in a list. For this, we don't really need to pass an access mode anymore since the read mode is the default access mode of the open function. This time, we'll wrap the code in a new function named fileReaderList. Notice how it retained \n when it read the file? Let's try to get rid of this using the strip function. Let's update the function to iterate through the list and display each line. Once we save and run this, we should see the output looking just like how it looks on the text file. And just like that, we already know how to open, write, and read files in Python. This doesn't only work for text files, but also for other file extensions such as CSV files. For CSV files, you need to import a built-in library named CSV. Using the import keyword, you can import any library you need, including third-party libraries, as long as you have it installed. I'll walk you into the package installation process in a minute. For this, I have here a sample CSV file named samples.csv, containing random names and sample grades for each person.
Once we save and run this, you should see a list containing the values specified per row on the CSV file. Amazing, isn't it? There's so much more to explore with the CSV library depending on your needs. Simply go to the Python's documentation for the CSV library to know more about the other functions available. And just important to add, being inquisitive about documentation isn't just for this library. In order for you to understand and utilize libraries at their best, please make it a habit to check out their documentation. Now, before we end this module, let's walk you through Jupyter Notebook and package installation. The Jupyter Notebook provides you a front-end interface for your code, meaning you can add content, write, and execute code within this notebook. It's just like a Word document, but much more interactive. This is really useful for collaborative activities and reporting. In fact, I'll be providing Jupyter notebooks for additional activities that you can dive into whenever you want. First, let's show you what it looks like. Let's go to jupyter.org, scroll down until you see Jupyter Notebook, and click on Try it in your browser, and then click on Try Classic Notebook. Once it loads up, it should give you an idea of what a Jupyter Notebook would look like. It even has a tutorial ready for you. You can deep dive into that if you want, but I'll also walk you through the installation process. Now that you've seen it, let's install it by clicking on Terminal on your PyCharm Edu IDE. Type in pip install notebook and simply hit enter. This is the standard syntax when installing any third-party Python library. The PyPy website also shows this command at the top of each library page for easy reference. After installing, it should open a tab in your browser with the same interface as the one we saw a while ago. As you can see, it's displaying the files inside your current PyCharm project directory. Now, to open and explore the complementary Jupyter notebooks I've created for you, simply upload them by clicking on the Upload button. Make sure that the files you're choosing have the extension .ipynb. Lastly, just to give you an idea on how to create your own Jupyter notebook, click on New, and then choose Python 3. This should open an autosaving untitled.ipynb file. You can easily rename the notebook by double-clicking on the name at the header. Let's rename this My First Notebook. Now, see how it says in square brackets at the left side of the interface? This means that the current line is for Python code. If you want to start with some text, let's just select Markdown on the drop-down at the top. To use headings for titles, simply use the hash sign at the beginning of the text. The more hash signs at the beginning, the smaller the heading gets. Let's try the following. After this, click on the Run button to see the differences. To edit, simply double-click again to activate the editor for that portion of the notebook. By default, Jupyter Notebook produces a new editor for Python code once you click on the Run button. So if you need another Markdown editor, simply change it using the drop-down again. Otherwise, we can go ahead and put some code. Once you click on the Run button, it will show the output at the bottom. See how convenient this is? If you want to save and leave the interface, click on the File button and then click on Save and Checkpoint. After that, click on Close and Halt to go back to the Jupyter directory. To close the directory and stop it from running, click on Quit at the top right corner. After that, you'll see this message saying, "You have now shut down Jupyter. You can now close this tab. To use Jupyter again, you will need to relaunch it." Now that you know how to open and create files on Jupyter Notebook, I believe you're now ready to go and explore on your own. In this module, we learn how to do string manipulation, file operations, as well as how to install and use Jupyter Notebook. I hope this 5-module course helped you learn the basics of Python. Please feel free to browse through the complementary Jupyter Notebook files and even the free Python course the PyCharm Edu IDE offers to learn more about this wonderful programming language. Congratulations for reaching the end of this course. If you want to learn more, feel free to explore other world-class learning modules.